Okay, so we have question 9. It says a coil with 200 windings and a surface area of 2.8 times 10 to the power of negative 3 meters square is rotated at a constant speed in a constant magnetic field of 2.5 Tesla, and EMF of 3.5 volts is induced in the coil. Now 9.1 says consider the following statement. The magnitude of the induced EMF across the ends of a conductor is directly proportional to the rate of change in the magnetic flux linkage with the conductor. Now they say name the law represented by the above statement. So we know that that is the definition of Faraday's, right? So that's Faraday's law. 9.2 says calculate the change in magnetic flux if the change of the coil relative to the magnetic field changes from 0 degrees to 90 degrees, right? So now we are required to calculate the change in magnetic flux, and then we know that one goes as change in phi, like that. So having to answer that, we have change in magnetic flux is equals to BA cos theta finally minus BA cos theta initially, because we can see that we are given two angles there, right? So to calculate the change, it is the magnetic flux finally minus the magnetic flux initial. Having to look at this, we can see that BA here is a common factor, so we can just factor out the B and A, and then we'll have cos theta finally minus cos theta initial. Now at this point we can go ahead and start to calculate. So we are given the magnetic field strength. The magnetic field strength here we've been given to be 2.5 Tesla, right? And then the area, so this is B, and then this is our area here. So that's all that we need, and the angles 0 and 90 degrees. So we have B 2.5, and then the A, that's 2.8 times 10 to the exponent of negative 3, and then substituting our angles, we have cos. So they said from 0 to 90 degrees, so 90 is the final angle and 0 is the initial angle, right? 0.07 Webers. 9.2.2 says calculate the time it takes the coil to rotate from 0 degrees to 90 degrees. Now having to calculate the time, we know the only formula that includes time is the one to calculate the induced EMF. So we have this, and then having to read our statement again, we know that we've been given an EMF of 3.5 volts, and then we are given that we have 200 windings. So this is our N and this is our EMF, and then we are looking for time. So substitute 3.5, the induced EMF, and then substitute the number of windings, that's 200. But remember, in the previous question we calculated change in magnetic flux, that's negative 0.007 Webers, and then over delta T. So having to calculate delta T, let's make it the subject of the formula by cross multiplying here. So we'll be having 200 and then 0.007 over 3.5. Now if you punch all that in your calculator, your change in T is now 0.4 seconds. 9.3 says by what factor will the induced EMF change if a coil with 100 windings is used under the same conditions? Give a reason for the answer. Now for this one, we'll have to observe what happened here. The initial coil had 200 windings, but then the one that is used now is 100 windings. So knowing the relationship of EMF and the number of coils, we know that they're directly proportional. So that is to say that if the number of coils increases, we also expect the EMF to increase. If we double the number of coils, we also expect the EMF to double, right? But then here what happened? Initially the EMF was 3.5 volts, and the number of turns on the coil was 200. Now the number of coils is 100. So we'll say this is before and then this is after, right? So now we have 100 coils. Knowing that E is directly proportional to the number of turns, if we halved the number here from 200 to 100, that's a half, right? So what will happen to the EMF? We also expect the EMF to be half the magnitude, so that's 1.75 volts. So to answer that, by what factor has it been, will the EMF decrease? We say it will decrease by a scale factor. It will decrease by a scale factor of half, right? So a scale factor of 1/2. The reason being what? We know that the EMF is directly proportional to the number of turns, right? So now we can say that halving the number of turns will result in the halving of the EMF. In the halving of the EMF. Right. Awesome.